Okay, go back through your examples. Hint, hint, notes. Section 4.6. Where did we talk about a mapping? Okay, what does a mapping look like? I don't know. It's Game Club, I just roll with it. It looks like Clone Wars Mace Windu's head on Cat in the Hat, but no hat. Which, given that crew, could be exactly what they drew. Okay. You have a function, you have a domain. Go find the range. Once you got that, check through your notes, particularly the first few examples of 4.6. What is a mapping? What does that look like? You are on the right trail there. What is a mapping? Again, make sure these are nice and labeled. Again, anyone who did not yet finish that test from last time, make sure that you have that done before, I would say before lunch Thursday. That way I can have everything in the gradebook before the weekend for the midterm. By my count, we will have quiz 2 on Wednesday next week. And I would really like to have those graded that night so that I can have an up-to-date grade for conferences. Because we all know, well, y'all don't know, you're freshmen. Freshman parents are our #1 attendees for conferences, and it's usually because they're just not sure how the whole high school thing goes yet. If you got older siblings, maybe they won't be so keen to come, but okay. Anyone still rolling? We all found the magic words?
Just ran out of light.
Bruh. Okay. You can go 0.7. You don't use a highlighter to do math. That just hurts my eyes. All right. So look like everyone had the right idea. If I have f of x is 3x squared, then to find all the stuff for the range, I'm going to take turns plugging all those in. If I throw negative 4 in there, negative 4 squared is 16. 16 by 3 is 48. If I put a negative 2 in there, negative 2 squared is 4. 4 by 3 is 12. Put a 0 in there. 0 squared is 0. Times 3 is still 0. Plug a positive 2 and a positive 4 in there, you get a 12 and a 48 again. Okay. Now for those of us who have negatives on there, don't go changing it. Okay, we'll call that a 4 out of 5. If you had a negative 48 and a negative 12, what went wrong? What did you not do that we keep saying to do when we plug things in a calculator? Parentheses. Remember, if I say 3 parentheses negative 4 squared, order of operations says negative 1 times 4, take that and square it. Okay? Parentheses, parentheses, parentheses. Super important. Okay, I got my range. Now we're going to get the mapping. The mapping is, here's my domain. Negative 4, negative 2, 0 to 4. Here's my range. It is 0, 12, and 48 only. And then you cycle the trash compactor, right? You say negative 4 goes to 48. You say negative 2 goes to 12. You say 0 goes to 0. You say 2 also goes to 12. And you say 4 also goes to 48. Okay? That's mapping. You have the line or the arrow or whatever to say this maps to this. This button does that thing. This input goes to that output. This domain goes to that range. And then you answer it with the final business here is that a function? How do I know? It is, but why? Can we put it into words?
The domain is going into 2.
Pretty close. I'd call that like a ground rule double. Every element of the domain is going to one element of the range. Now, it's okay that both 4 and negative 4 are both going to 48. That's fine. I can have more than one Mountain Dew button on a pop machine. As long as I press this, it gives me the Mountain Dew. I press that, it gives me Mountain Dew. I don't press either of them and it spits out Cherry Coke. It's doing what it's supposed to do. So it is functional, yes. So, did we have the mapping at all? Did we connect the lines appropriately by not repeating our 12 or our 48? Remember, we only read them once. Okay. Did we say yes, it was a function? Did we have the correct values for the range? And then, this is not the right answer. Did we say that my range was 0, 12, 48? Nothing else, because you're not supposed to repeat it. Remember, I don't say Dominic twice. He was in the room at lunch. He was in the room again in fourth block. He's going to be here again after school. I can't get rid of the kid. Okay? I don't say Dominic 3 times. I just ask, who was in the room today? You say Dominic. Okay? Now, the whole thing's going to be crapped out if you had your negatives up here, right? Okay, there's a handful you're like, yeah, got me. Okay? If you had negative and negative, that means this whole thing is your range. So you'd take 1 off for missing the whole negative parenthesis thing. Then down here, your -4, -2, 0, 2, 4, they all just go straight across, right? 5 of them. Well, you still mapped what you had correctly. And it would still be a function. So if the only thing you goofed was back here, you got a negative here and here, which means you didn't have the reduced down range. I would call that a 4 out of 5. And I know there's a couple of you that did it. I saw it as I was coming around. Okay? But you found the values. You stated the reduced down range. You have a mapping. The mapping is correct. You said it was a function. Okay? So, we did a pit stop last time and said we need some extra practice. I suppose I don't need this. We weren't in the book. So, in the intervening 4 days, I had 2 kids ask just some quick questions about a thing. I had a couple say, you know what, that practice was what I needed. I feel solid on it now. I was lost last time. Speak now or forever hold your pieces. Anything from the front page? '16 front page. Okay. Okay, that one was a little goofy. Okay, write a rule that is an example of a nonlinear function that fits this description. So it's a function, and they say the words, A is a function of B. That means A, in terms of B, is do stuff with B, and it will get me A. That's what A as a function of B means. Kind of like my gas mileage is a function of how far I've driven. My earnings are a function of how many hours I put in this week. Okay? Maybe that'd be a good thing to go back somewhere in your 4-6 notes and write that. If I say y is a function of x, this is my output, this is my input. And that's the words to say f of x gets me rule with x equals y. Okay? And honestly, I don't know if anyone just straight up did number 16 on their own first try through without getting at least a little help or at least a point in the right direction. So, Words mean stuff. All right. I need to make this work. When B is 49, A is 7. So I need to make a rule, A of B, such that, here's my rule, and when I plug in B, B is 49, it'll spit out a 7. So can you think of a rule that I shove a 49 in and it spits out a 7? 49 divided by 7, right? So x divided by 7 is one of the rules, not x, sorry, b. B divided by 7 is one of the rules I could have chosen, because I would throw in a 49, it would spit out a 7. Okay. I think I saw some kids also say B minus 42. I saw some kids do that. Throw in a 42. Square root. I don't think I saw that one, but that's a good one. Square root of B. Right? Square root of 49 is 7. So there's a whole bunch you could do. And you could get more complicated with it. You could just start going math crazy on it and make up the most ugly, complicated, big expression you want to think of. Go for it. It's not necessary. Any of those work. As long as I can throw in B and it spits out 7, you have followed the rules. Okay? And I'd say there was a good number of us who asked that one. What else? Yes, ma'am? Oh, okay, anything on the front page? 11 on front page. 11. Okay. Jose is 3 years younger than 3 times his brother's age. Write a rule that represents... there's more to that. Write a rule that represents Jose's age, J, as a function of his brother's age, B. Okay. So what's the input? What is the thing I'm going to know? The brother. So that means J in terms of B is how I set up my function. Jose's age in terms of his brother's age. I'll know his brother's age because that's my input. And then I go all the way back into semester 1 and I translate that first sentence. Jose is, J equals 3 years younger than, we talked about than an awful lot, younger than. If you're 3 years younger than your sibling, what do I do to your sibling's age? Minus 3. And it goes at the end. That's what the then does. 3 times his brother's age. Okay, 3 times his brother. Okay, so that's how I start. Then, if I'm using true function notation here, I'm going to say Jose in terms of brother is 3 times the brother minus 3. Now they're going to tell me brother is 5 years old. So I'll plug in a 5. 3 by 5 is 15. 15 minus 3 is 12. Jose is 12 years old. Now another part to go with these, and it's going to be kind of the recurrent theme for chapter 5. You notice these ones were linear, so they followed that y equals rate x plus start. Okay, there's a lot of linear functions that'll follow that. The rate is 3 times brother's age. The start is 3 years younger than that. So I noticed a few of you using that one. That's good. Anything else on front page? How about the back? Oh, 15 on front? Okay. Well, 15 front. Okay, write a function rule for the area of a triangle as soon as I read that. Nothing else. I'm cracking open the back of my book. I'm Googling. I'm doing something to find area of a triangle. Area is 1/2 base times height. And then they go and say the base is 2 meters less than, 2 meters less than, so I'll minus 2 at the end of something. Base is 2 meters less than 4 times the height. Base is 2 less than 4 times the height. Okay. So if I say B is this stuff, then I will replace B with that stuff. Now I have A is 1/2. It's not B anymore, it's this stuff. And then simplify it like we're back in first semester. That's a 1/2, by the way. It's just a really bad one. So if I take half of 4h, I get 2h. If I take half of -2, I get -1. If I take h times that stuff, I'll get 2h squared minus h. Now go find the area of the triangle when its height is 8 meters. So now I'm replacing those h's with 8. So 8 squared is 64. 64 by 2 is 128. 128 minus 8 is 120. Not 1/20 yet, doof. 120. Before someone goes trying to call a brownie point, I know that this isn't 100% finished yet. It's like 93% finished. What did I forget? I don't have to draw it, but I do have to know what the crap I'm talking about, right? 120 what? Now drawing the triangle can definitely help us out, especially with the formula. Okay, when in doubt, draw it out. That was a thing I said about 90 billion times last week doing ACT review with kids. Since it's 8 meters height, since the base is so many meters, then I need to say that's not just 120, that's 120 square meters. Okay. Okay, 120 square meters is a lot different than 120 square feet. Is a lot different than 120 square miles. A lot different than 120 acres. Okay. Labels matter. 120 square meters. Think of a triangle that big. That'd be like, you need the commons to fit it. Right? Well, no, height is 8 meters. We could fit it in here. It'd be close, but we could fit it in here. Think a triangle that takes up our whole floor. Okay. Backside. There were a couple of them we had to graph, but that was something that we, did earlier, had a little practice with. Yes, ma'am? 14? 14, very bottom. Charter boat travels maximum rate of 25 miles an hour. Function d of x, distance of x, equals 25x, represents the distance in miles. The boat can travel in x hours. Charter boat travels a maximum distance of 75 miles from the shore. Reasonable domain and range and graph. So, I'm going to start with an L graph because it doesn't make sense for me to travel negative miles. It doesn't make sense for me to have a graph that goes to negative hours. So I'm just going to be up in quadrant 1. Okay. What's the furthest? Says X hours. What's the longest that I can drive? Drive a boat? Is it drive a boat? Float a boat? What's the longest that I can float a boat? That's not 75 minutes. That's 75 miles. Okay, now you said 3 hours. How'd you get that? Okay. If it's 25 miles an hour and you can travel a distance of 75 miles, then the longest that you could have driven was 3 hours. 1, 2, 3. And distance in miles. Okay, now it does say the maximum distance is 75, so maybe I go, there's 25, 50, 75. If I really wanted to, I could get 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There we go. Graph's going by 5s. I suppose I'll label that, say it, but I actually should write it. 25, 50, 75. Okay. So they travel 25 miles an hour, means at 0 hours you have gone 0 miles. At 1 hour you have gone 25 miles, 2 hours, 50 miles, 3 hours, 75 miles. And they ask, reasonable domain and range, not, oh, would this be linear or nonlinear? That was one of the things we did before. Makes a line, right? Makes a straight line. Would this be continuous or discrete? Should I just leave those dots or should I fill in the dots? Think about x. What is x in the problem? Hours. Can I drive a boat for 1.3 hours? Yeah. It's not like drive for an hour, stop. Drive for an hour, stop. I can't. Nope. It's been an hour and 10 minutes. I'm gonna pull up to the dock and someone's like, no, you can't. No, just go do laps. Come back in another 50 minutes. Okay, it doesn't work that way. You can actually be continuous. So I would actually connect the dots. It is a continuous graph. It is linear, and it says a reasonable domain and range. So domain is your x's. And it was everything from 0 to 3. How do I say everything in there? Not just 1, 2, 3. How do I say everything from 0, 0.19, 0.925, 1 1/4, 2.99, 3? How do I say all of that in mathese? Students who just did compound inequalities at the end of first semester. What's the lowest I can go?
0.
What's the highest I can go? 3 hours. There you go. My domain isn't a bunch of numbers. It's an inequality to say all the numbers in here.
And how do you guys get paid?
The 25 miles per hour with a maximum distance of 75 miles. We had to do 75 divided by 25. We had to work backwards to find it. Okay, what about range? What's the least amount of miles I can go? Most amount of miles. So I say my range is from 0 to 75. Or I suppose that should be D for distance. This business with graphs and analyzing and what does it mean and how's my function input look, it doesn't end. Okay, I just finished a bunch of graph analysis stuff with pre-calc. This weekend I ran into a former student who's at School of Mines. He's doing an internship with a professor right now and they're doing models of dark matter. It doesn't stop. You have to be able to analyze graphs and functions. As far as you go throughout math, the science section of the standardized tests that you take to, get into college and get scholarships, the science sections are just, can you read a graph? No joke, like basic freshman, sophomore level science knowledge and can you read a graph? That's what they are. So that's why we're taking the time to go through this. And why I'm willing to keep going if we need to. What else? 12? Ew, fractions, right? Find the range given the domain. Y'all, grab a calculator. Let the calculator do the hard work for you. Everywhere that there was an x, you're going to plug these numbers. So, parentheses 0, parentheses squared, plus 2. That thing. Parenthesis fraction. A bunch of you have seen that alpha y equals using our bumblebees. 1/4 parentheses squared plus 2. 33/16. Okay. Now that's why I say let the calculator do the heavy lifting for you, because do we remember this thing squared? You square both parts. And then to add things together with a fraction, you need to get common denominators. And say 2 isn't really 2. It's 32/16. Okay. I don't know too many kids who want to just do that over and over. Y'all passed middle school. You should know how a fraction works. I take that back. I assume that you passed middle school. State law says that we can't keep you back in middle school even if you diddly do nothing. Even if you have 0 skills from middle school because you did absolutely nothing, they are not allowed to hold you back unless it's at parental request. So maybe you did something in middle school. That's also why I was really frustrated when they got rid of pre-algebra at the high school. We used to have a pre-algebra class. Our administration really wanted it gone. Now algebra half is the lowest it goes. So for all those kids who come up from middle school having not really done anything or really struggled, this is as good as you're going to get. It's kind of, the meme of the parent with one kid all happy and smiling while the other one's behind them drowning. Okay, we just kind of kick you into the pool and say swim. Plug it in, plug it in, plug it in, plug it in. Write them down. That's your range. That's it. But use the calculator, please. Like, let the calculator do the heavy lifting for you. At this point in high school, you're more than halfway through your freshman year of high school. Do y'all have your own scientific calculator? I know, like, spending that 10, 15 bucks on the calculator when they have them at school, I know that's a privilege. But if that is something that your family has access to, if you get a hand-me-down from a sibling, a cousin, talk to some of the math teachers. We might just have an old one laying around that you can have, but you should have your own scientific that you are going to get familiar with and use throughout high school. So you can do the fraction stuff on there without having to fart around with your phone because you don't have access to the phone on the test. Okay. No joke. Like that one right there that Aiden's got, this thing, they're 10 bucks. Okay. And this will almost do your taxes. This thing is great. Okay. It's 10 bucks. It is hopelessly more complicated than you will ever need. And it'll get you through all of Algebra 2 and even into pre-calc. The only things it'll miss out on is the graphing functions. Okay. Anything else out of the homework? 7. Those ones were actually nice because it was just shove number in. W of x is 60x. It's the number of words at x minutes. So how many words can you type in 9 minutes? They're saying plug in a 9. It's just getting used to that notation, that W of 9. It doesn't mean W times 9. It says words of 9 minutes. Okay. What else? 19. Well, it's towards the bottom. It's probably got more words involved. All right. Or fractions. It's always the... Oh. Well, I assumed. We all know what that does. Graph them on a coordinate plane. All right. 5, 6, 7, 8, 9, 10, 11, 12. 5, 6, 7, 8, 9, 10. Plot on a coordinate plane. 1, 6, 1, 2, 3, 4, 5, 6, 2, 8, 3, 10, 4, 12. Label your axes so we know what's going on. X, Y, no special words associated with them, going by ones. Write an equation. Remember that rate x plus start business. What was it doing every time? So that's my rate. Y equals 2x. And then to figure out start, I follow my pattern back to where it hits 0. Or I can just go up to 0 instead on the table. So if this was plus 2, plus 2, plus 2, I'll minus 2 to get my starting value. So I can either do it on the graph or I can do it through the table. Is it a function? Does every X button go to one Y? I press the 3, it only does one thing. Yeah. Now when I say yes, I have 2 answers available to me. Option 1, I'll say that it passes the vertical line test. Now that I have it graphed, it only ever hit once on every vertical line. Or I could say every x maps to one y. Every element of the domain goes to one of the range. All right. So in that amount of time, we've basically done half the assignment right now. I'd say it's time to skedaddle into 4.7. Okay. 4.7, it's the last section of the packet. Assuming that we can finish it today, then we will have Chapter 5 packet on Thursday. Go! Argue with your neighbors. Figure it out. I know it's showed up super dark on the copy, but hopefully you can all still tell what's going on.
I don't have mine.
There's more right there.
No, there's not.
What?
There's none left. There's 4-1, but there's not 4-4.
We had like 40 of these things. Why do we not have any more?
Because they all disappeared. They vaporized.
That's okay. You can still do notes in a notebook. Old school. Look on with your neighbor, just copy it in a piece of paper. Okay, what are they doing every time? Every time they add a new section.
It goes up by 3.
Okay, you already have the one that you're connecting to, so I don't need 4 more pieces, I need 3 every time. So I'd be up to 13 pieces grand total. What if I said I wanted a 28 section fence? Figure it out. Now I need a 28 section fence. Is it? I think so. What'd you do? Okay, I'm starting with 4, and then I'm adding 3 pieces every section. But you got to be careful. It's 3 pieces times how many more sections. If I start here, how many more sections am I adding? Don't put in 28. I need to put in 27, right? I'm starting with the initial 4, and I'm building 27 more sections on that for a total of 28 sections. Okay? So grand total, there'd actually be 85. Sneaky. Okay? It boils down to this idea of pattern recognition. Anyone who's ever had to sit in a room with someone and they ask you a bunch of questions and flip a book at you and, you know, what's next, what comes next with this, here's a bunch of colored cubes, make the picture kind of thing. Okay, a lot of standardized tests that people use in terms of education and mental health are built off of pattern recognition because it's something that most people can do to varying degrees regardless of their language ability. You ever heard stuff like dolphins are smarter than monkeys? You know, if dolphins had opposable thumbs, they would rule the world kind of thing. Like you can find out which animals are actually smarter than other ones. It's because pattern recognition. Why do you think we can train animals? Have you heard of Pavlovian conditioning? Ring the dinner bell, the dog's mouth starts drooling. Okay. How many of you getting really close to 11:20 in whatever your second block class is, you just start getting hungry? Okay, it's a pattern, and your body has adapted to that pattern. Anyone can do it, all the way down to a turtle. We're a little smarter than turtles. I can give you symbols. Those symbols are numbers. Those numbers have a pattern, and you can tell me what the pattern means. Describe the pattern for each sequence. What are the next two terms? So the first one, I'm basically asking myself, are there adding, subtracting, multiplying, or dividing every time? Okay, and I see that the pattern is plus 3, plus 3, plus 3. So, describe the pattern. I would say, add 3 each term. What are the next two terms? 17 and 20. Next one. Am I adding, subtracting, or multiplying? By. So I would say I double each term. Or just take each term times 2. Whatever you want to write. So, double, double, 40, 80. You have 4 down there. Some have negatives, some don't. Some have decimals, some don't. Some got big numbers, some don't. All 4 of them, can you write not just what the next terms are, but can you articulate what the pattern is? Tell me they are adding, subtracting, multiplying, or dividing, or squaring, or square rooting. What are they doing every time to get from one number to the next? So you tell me what the pattern is, and then tell me the next two terms. Whose class is this in? Okay. That's really cool. You know, argue it out with your neighbors too. If you're not sure what the pattern is, okay, confirm with someone else. What do you got and why?
Would this be backwards? It's like 15. Oh, wait.
So if going this way you're multiplying by 2, then going that way, what are you doing?
Dividing by 2?
There you go. Remember, it's not just enough to write the next two terms. You have to tell me what is the pattern. What are they doing each time?
What is... I'm confused on C.
Okay, if you ignored the signs, what is it doing?
Going over. Or doubling.
Doubling. Okay, and then it's swapping signs every time. So if I'm multiplying it by 2 every time, and I'm going negative, positive, negative, positive,
Switch.
what can I multiply something by to change its sign? Don't overthink it. To change a sign.
Negative.
A negative, right? You multiplied by a negative 2.
Oh.
That's it.
Oh.
Okay, don't overthink it. Hi.
What is undoubling called?
Dividing by 2. That's it. Or multiply by half. Right? Same thing. Oh, that's a legitimate question. Sometimes we just go brain fart mode. I've been I was texting with a buddy the other day and said that his wife literally forgot the word for what was it? For daughter. Like just the word just escaped her vocabulary. Girl child that came from me. Like that's how she described her own child. Just forgot the word daughter because it's been a hell of a day. Okay. Hey, we all jokingly say words are hard for a reason, because they are. Okay, it looks like we got enough time. Most of us got this figured out. Poke. All right. First one, what are they doing every time? Describe a pattern in each sequence. Y'all, there's nothing wrong with just saying add 6. Okay, that is the pattern. I'm adding 6 every time. And the next terms will be 29 and 35. Okay. What is undoubling every time? I don't have to say divide by 2. I could also say multiply by half. So either of them, there's my rule, 25, 12.5, or 25 halves. I prefer 25 halves because then I can keep going by just doubling my denominator. Then I could say 25 fourths, 25 eighths, 25 sixteenths, 25 32nds, 25 64ths. Okay? I would much rather do that instead of 6.25, 3.125, 1.5625, I think. Like they start getting the decimal train just keeps getting bigger and bigger. Instead, I could just double my denominator. This one, if you all caught it or overheard it, it is doubling every time, but it's also swapping signs. So I'm multiply by negative 2. That's how I keep flipping the switch off and on, off and on, off and on. So I'll have a positive 32 and then a negative 64. And last one, be careful. Am I adding or subtracting? Okay. But the numbers are getting smaller. You're moving further to the right on the number line. Okay. So I add 4 every time. Be careful when you cross the boundary across 0. It's 1 and then 5. So this is basic pattern recognition. These are examples of what are called arithmetic and geometric sequences. We'll see them off and on through math for the next how many years? Okay. Recursive formula. What word or words do you hear in recursive? Cursive, if you're thinking about the writing. What's another one? Recur. That's the one. Okay. Cursive, we're just used to. Do you still have teachers who make you write in cursive?
No.
Did you have any in elementary?
Yes. Yeah. And third.
I hated it. I hated it so bad. Do you know why we wrote in cursive? Okay. Cross-curricular, here's a little bit of history for you. Why would we write in cursive?
For signatures.
Okay, that's the only practical purpose of it right now.
That's what I was told.
Okay.
I was told to read.
Y'all, if you need to write a lot of stuff now, a lot of stuff, I tell you, you need to do a 200-word paper. Sorry, 2,000-word paper. There we go. You got to do a 2,000-word paper on a topic of your choice. It is due on Monday.
You end up writing in cursive even if it's not supposed to.
How many of you are going to write that by hand? Who's going to type it? Okay. In modern times, we type things because that's the fastest way to communicate the written word. What happens before we had pens and pencils that had integral inkwells? You've seen all the cartoons and the movies with a calligraphy pen, with a feather, a quill. The reason that you wrote with cursive is because you would keep the stream of ink going. Because every time you picked it up and then put it back down, it would drip, drip, splat. Drip, drip, splat. Imagine that every time you pick up your quill as you're writing. You would do cursive because it would just keep the stream of ink going instead. Which means it is 100% archaic and obsolete, and we shouldn't be doing it. Obsolete, absolute. Obsolete. Boy, I'm tired. Here we go. Recursive. Recursive, the one we were looking for was recur. Recur means right after the other one, right? Do it again. A recurring nightmare. Okay? If I'm going to write a recursive formula, I'm going to say, what am I doing every time? Okay? So a recursive formula has two parts. A sub 1. Okay? Maybe you've seen this in science before. You'll see it again in math. See how that's not upstairs like an exponent? It's downstairs. If it's upstairs like an exponent, that means I'm going to do it this many times. If it's downstairs, it's telling you the name. A sub 1 is the first term. So you'll just tell me 70. Here's where I start. A sub 1, the first term, is 70. A sub n, meaning the nth term of it. Any term that I want, I'm going to take the term that came right before it and add 7. Okay? N sub 1 means the first term. A sub n means the nth term. So A sub n minus 1 means the term that came right before that. Right? If I said find the 8th term, then 8 minus 1, that says take the 7th term and add 7 to it. Okay, this notation's a little goofy, but this sequence notation is something you'll see off and on again for the next how many years. And this is the first place that we ever see it. Now, it's easy to write a recursive formula because it's going to be the same setup every time. You're just going to change these two things. That's it. You start by saying a sub n, or a sub 1 is here. I start here. And then I'm going to do this to every term. Okay? Super easy to write. Let me double check. I want to make sure I'm in line with the other classes. That's how you're supposed to write it. But I think this book might dumb it down. Yeah, they do. All right, they really dumb it down. No, what I showed you was right. It's just they're going to give this to you formulaic instead. Recursive, explicit. Okay. They want you to write it like this. God, that's so dumb, though. All right. I mean, I suppose it gets you ready for rate x plus start, mx plus b. Okay, maybe write that one down next to it. Sorry, y'all. This is backed up like 6-7 years from the stuff that I do every year. So I'm just. Why we show it this way and then just change it all on you later. So they want you to say a sub 1 or a of 1. The way that you're supposed to do it is a sub 1 is 70, a sub n is a sub n minus 1 plus 7. The way the book wants you to do it, and I have to show you this because this is the way that the other classes will be doing it, is they want you to say a of 1, like a function, is 70. So a of n is going to be 70 and we are going to just add on n sevens. Like that. I mean, I understand why they're doing it that way. It's leading into linear functions. I'm thinking about quadratics and cubics, and that's not where we're at yet. So left is the way that you're going to write it for the rest of time. Right is the way that you're going to do it in this book. Okay? Well, conversation. Which one makes more sense to you? The one on the left is the official one, and all I change every time is this and this. This is set up almost like that rate x plus start. where you're going to change this, this, and this every time. Which one makes more sense? Yeah?
So on that one,
Left or right?
on the left, so it's always written right like that, except for you just put your start and then you.
Yeah.
And then you just put what you add or.
Yeah.
Add
Yeah.
okay.
It's just getting used to this way of writing it. This means the previous term.
Okay, so the a n minus 1 is the previous term.
So a sub n means this term. A sub n minus 1 is the term right before that. Oh. I know it does, but I also don't want to throw more complicated notation in there if it bothers us. Who likes left? Who likes right? Who doesn't care? Okay. Well, then I guess we'll just go left because more people said that. Okay. Write the recursive formula for each of these. And what is the 9th term? So I'll do it one more time. I'll do ugly down here. I would say a sub 1, the first term is 7.3. The nth term, whatever term I'm looking for, is the term that came right before it, and what do I do every time? 0.5. So there's my formula. And it is 2 parts. You have to have both to have the full formula. And then after that, it says go find the 9th term. So grab yourself a calculator. Plus 0.5 equals, plus 0.5 equals, plus 0.5 equals, plus 0.5 equals. Do that until you hit the 9th term. I got about the age that sophomores start creeping on middle schoolers. 13.3. Y'all know that kid. Stay away from that kid. That ain't right. Right? Plus 0.5. 9.3. 9.8. 10.3. 10.8. 11.3. 11.8. 12.3. 12.8. 13.3. I would like you to fill. Hi.
Do you need to see 5 more? Do you already have 4?
Oh, did I do 9 more?
Maybe 11.3.
Yeah, I went too far. I went way too far. Yes, I went way too far. You already got 4 there. You only need 5 more. 5, 1 half, 2.5, 2.5, 11.3, yeah. Okay, now that dude's just straight up going to jail. I mean, going to jail either way, but still. Reading the problem explains the problem. Do the other 3 before I sleep deprive my way into more brownie points. math.
Was it the harder sheet than the ninth one?
I just kept adding 0.5.
That seems so tedious.
Exactly.
No.
Which is why then we're going to get explicit formulas. Recursive are easy to write, annoying to find. Explicit are annoying to find, but easy to write.
So, couldn't I just do like 6 plus 9 plus 3, or 6 times 9 plus 3 to get my answer?
Why 6? Oh, you're doing A. Okay.
Yeah.
8.
8?
Because if 3 is the first term, the ninth term will be 8 more down the road.
Oh.
Yep. Hmm? Exactly what we just told Grace. Okay, this is good thinking because you're starting to head towards the explicit formula instead. Okay? You say a sub 1 is 3. A sub n is a sub n minus 1 plus 6. And I got a couple kids already saying, well, couldn't I just take 9 times 3 plus 3? No. Why not? It's very close. Okay, let's write them out. 3, 9, 15, 21, 27, 33, 39, 45, 51, 55, no, 57. All right. Words are hard. Numbers are even worse. The ninth term, 1, 2, 3, 4, 5, 6, 7, 8, 9. What did you have? Okay. So yeah, you're adding 3 every time. So 3 times some number of times I'm going to do this, plus the 3 I started at. But if I start at 3 and I'm going to the ninth term, how many more times will I go? I won't go 9 to the ninth term. I'm going to go 8 to that term. Okay? Also, it'd be 6, not 3. So I don't know why kids are saying 3 times 9. Okay. You got the other ones? A sub 1, 23. A sub n. Every time, I'm going to take the previous term and add 12 to it. So go find the ninth term. I need 5 more terms after this. So now I can do 5 more times. So 5 by 12 is 60 plus 59. Okay. I have red. A sub 1 is 97. A sub n is a sub n minus 1 minus 9. Go find the ninth term. I need to go 5 more times. So 5 times negative 9 is negative 45. Negative 45 plus 70 is 35? No, 25. Okay. Or you just subtract 9 equals, subtract 9 equals, subtract 9 equals, subtract 9 equals, subtract 9 equals. Okay? And Grace said it perfectly. She said, this is kind of tedious. Yeah, it is. Explicit formulas are very easy to write. Put this number here and this number here, done. But they're annoying to go find the ninth term. What if I said find the 29th term? Ew. Okay? Ew. You ever seen warning, parental advisory, explicit content? The word explicit means get straight to the point. Don't beat around the bush. Don't mince words. Don't say maternal fornicator. Just straight up say you MF. Okay? Straight to the point. That's why they say explicit content, because it gets straight to the point. This is a formula that's going to go straight to the point. Formula good? Formula very good. They tell you what each thing means. A sub n is A of 1, so the first term. Y'all, this is written in ugly book notation. The way we're supposed to write it in upper classes. A sub 1 plus n minus 1 times d instead. It just, they're a subscript instead of parentheses. Okay. So, I start with this. I'll plug in what my first term is. I'll plug in the common difference. That's that rate that was changing every time. And then I'll just distribute and combine like terms like I'm back in first semester. And now I have a formula that goes straight for the throat. Okay, so I'll back up and do one of these. Say we had the one that I couldn't mental math. Well, I could, I just went too far. I would say A sub n is A sub 1 plus n minus 1 times d. Our common difference was 0.5. Distribute. And then I would combine like terms. 7.3 minus 0.5 is 6.8. Now this says, if I want to go find the nth term, shove n in there and you're there. Now I would say a sub 9, 0.5 times 9 plus 6.8. Done. Okay. Recursive formula. I need to do the thing, 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 to get there. Explicit formula. F you. I'm there. Explicit content, right? They don't beat around the bush. They just say what they mean. You all know those playlists that mom and dad walk by your room, you kind of hit that key a bunch of times. No? I know my kid's going to be freaked out the first time that I walk by his room and I'm also singing along to 1992's Whit Dre Day. So, writing the explicit formula, you have to decide, where do I start? I still need a sub 1. Common difference, what's changing every time? This time they gave it in context of a word problem. Online auction. Works as shown below. So you're going to start with a minimum bid of $200. The following bids are each going to go up $10. Okay, no Wreck-It Ralph 2 here where you just jump up $9,000. Okay? Instead, it's just up $10 every time. What is the 12th bid? So I start by saying A sub n is A sub 1, first bid, 200, plus n minus 1 times d. D is my common difference. The difference is it's going up 10 every time. There you go. Now I can clean that up. I can rearrange it into the formula. Write an explicit formula that represents this as a sequence. Okay. Disturbert, combine like terms. I'll have 10n I'll also have 200 minus 10, right, when I distribute. And 200 minus 10 is 190. So this is my explicit formula. I don't have to add 10, add 10, add 10, add 10, add 10, add 10 to get to whatever bid now. Now, when they say, what is the 12th bid? I go straight for the throat, mic drop, and say 10 by 12 plus 190. If I want the 12th bid, I'm just going to shove a 12 in for n. The 12th term. What is 10 by 12? 120? 120 plus 190. $310. Okay.
Would you distribute that 10? Would it be negative 10?
And then I added it to the 200. I cut out a step. Sorry. 200 plus 10n minus 10.
So it'd be plus 10 would be 210.
Negative 10 and 200. $200 minus 10.
Okay, yeah.
So, the explicit formula is a lot faster way of getting there. Now if I said, go find the 29th term, it's not a big deal because you just shove 29 in there. Someone just get Rochambeau'd? All right. Either that or a passerby really likes math. Okay. All right. Try it again. A sub 1 is your first term where I start. D, common difference. That's how much it's changing every time. Plug them into that formula. Plug in N and D. Distribute, combine like terms, rearrange it. Now that you got your formula, answer the question. What about after 15 rides? You know what? Since I'm betting not everyone has gotten to that point anyway, we're going to say you made a weekend of it. What about out of 45 rides? That way we can't have someone just brute force it.
So if it's decreasing by 1.75, would it be negative? Or, I don't know.
Yes. Okay. Listen to Sailor. Sailor is wise. That rate went down every time. So the common difference is negative because it's going down. Is that you? Okay. Okay. Plug in your 45. What's that? 7/4. 45, 75, quarter. No, no. It's going to be a small number. It ain't gone, but it's close. You